So this video is going to be about law of multiple proportions, and it is different than law of definite proportions. So law of multiple proportions states, when elements combine to form more than one compound, the ratio of the masses of one element that combines with the second element in the first compound to the mass of the element that combines with the second element in the second compound is a ratio of simple whole numbers. So the key here is the word whole numbers, okay? So when we do a ratio, okay, we're going to be doing ratios with this. We're talking about two different elements in two different compounds. So again, we haven't done too much with symbols yet, but this will be something that you might be familiar with. So we have a formula for water, which is H2O, versus we have a chemical called hydrogen peroxide. Hydrogen peroxide is H2O2. So just by looking at the twos, okay, hydrogens, you have the same number of hydrogens in both compounds. The oxygen essentially is a 1 here, and this has a 2. So this is a what we call a multiple proportions situation, where the hydrogen and oxygen can get together to make two different compounds, and their ratio is going to be a whole number. In that case, it would be a 2-to-1 relationship. So we are going to analyze some data to see how this works. So we're going to take a 10-gram sample of two different compounds, compounds A and compound B, containing only two things, cobalt and bromine. Cobalt is going to be CO, and bromine is going to be Br. Okay, just to save time writing it all out, you could write out cobalt and bromine, but again, just to save time. So again, these are all in masses. And we want to know if it demonstrates the law of multiple proportions. So since these are two different compounds containing the same two elements, I can do this. So I'm going to calculate what we call the mass ratio of cobalt to bromine, and then we're going to write another ratio. So there's two ratios you have to do. So I'm going to take compound A. and I'm going to do cobalt over bromine. So I'm going to take 2.694 grams of cobalt for every 7.306 grams of bromine. And when I divide those two numbers again, like in my previous video, the bottom number becomes 1. So I get 0.3687 grams of cobalt to every 1 gram of bromine. And I'm going to do the exact same calculation for compound B. So I'm going to take the cobalt, which is 1.973 grams, and divide it by 8.027 grams. And that's cobalt to bromine. And I will always tell you which one you're going to put what over what. This comes out to be 0.2458 grams of cobalt to 1 gram of bromine. Now, law of definite proportions tells us that A and B are two different compounds because I have two different ratios here. And law of multiple proportions, I have to do a ratio. There is no option to do a percentage here. That would be law of definite proportions. So multiple proportions, you have to do a ratio. So now I have to take A over B. Okay, I'm going to take A over B. And the reason I'm going to take A over B is because that's a bigger number than this. So it just makes your head not hurt to do the math. You can do it the other way, but then you're looking at more of a fraction, and sometimes that bothers people. So I'm going to take 0.3687 grams over 1 gram cobalt to bromine, and I'm going to divide that by 0.2458 grams of cobalt to 1 gram of bromine. So the grams of bromine cancel, and you're just left with 0.3687 divided by 2.2458. So take out your calculators and see if you could divide 0.3687 by 0.2458. And what you're going to get is about 1.5, okay? So that's saying, again, that bottom number becomes 1. So 0.3687 divided by 0.2458 ends up as a 1.5 to 1 relationship, A to B. Okay, so this is A to B. We don't like fractions, we don't like decimals. So what we're going to do is multiply by 2 to get the real ratio. So the real ratio is 3 A's for every 2 B's when you're comparing those two compounds. Again, law of multiple proportions states that it's always going to be a whole number relationship, always going to be a whole number relationship, okay? So we could write it out this way. We could say compound A has 3 cobalts compared to compound B, which has 2 cobalts. Okay, so it does demonstrate the law of multiple proportions because it is in a whole number relationship. It's not a 3-to-1, it's a 3-to-2, but those are whole numbers. Those are whole numbers. So again, the steps are you have to take one element over the other to get the ratio, okay? Then you're going to take these 2 separate ratios and also compare them. So there's a second ratio that you're always going to be doing. I suggest you put the bigger number over the smaller number and write it out as a statement. Okay, compound A has 3 cobalts compared to compound B, which has 2 cobalts, because again, the bromines canceled. So you are comparing cobalt to cobalt. You're comparing cobalt to cobalt. All right, so why don't you try this one? Carbon combines with hydrogen to form numerous organic compounds. 2 such compounds came into the lab and were analyzed. So carbon is going to be letter C and hydrogen is going to be letter H. How these compounds demonstrate the law of multiple proportions. So I would suggest you stop the video, you try the calculation yourself following the exact same steps I did before, and we are going to do carbon. You're going to put carbon on the top and you're going to put hydrogen on the bottom for your ratio. So do carbon on the top and then hydrogen on the bottom. Okay, so pause the video and then I will show you the answers. So I've now done the work. So I took compound A, grams of carbon, so 4.29 over 0.71 grams of hydrogen for compound A. And then I'm going to take 7.38 grams of carbon to 0.62 grams of hydrogen. So I get about 6 grams of carbon to 1 gram of hydrogen. And I get around 11.9, which we're going to round up to 12 grams of carbon to 1 gram of hydrogen. So again, we have experimental data, so the numbers may not come out to be pretty, but that's 11.9 is pretty close to 12. So again, I always suggest you take the bigger number and put that on top, just because it's easier for you to make a statement, which I want you to do. So you're going to put 12 grams of carbon over 1 gram of hydrogen, that ratio. So I'm going to take the ratio for B compound, and I'm going to put it over compound A to get a number of 2, which again, you can, again, figure that out pretty quickly by 12 versus 6. So the statement I want you to make is as follows. Compound B has twice the amount of carbon to hydrogen as compound A, because again, my hydrogens cancel, so what I'm comparing is the grams of carbon. So I could say there are 2 grams of carbon to every 1 gram of carbon in compound A. That's another way you could phrase it. But I do want you to do the math, but I also want you to do a statement associated with it, okay? So again, you're doing 2 different ratios when it does multiple proportions.